All right, geometry, welcome back to the Unit 5 practice test key. As I told you in class, do not worry about question number 14 on this one. That's actually a little bit more geared toward our next unit. It was still on this review from last year. So go ahead and don't worry about question number 14. Let's just look at the proof. That is question number 13. It says a proof with some missing statements and reasons is shown. It just wants us to fill in line 3. That's all we really care about in this one. But in order to do page 3 or line 3, I'm going to have to do all the other reasons and statements. So I'm going to go ahead and I'm going to start this proof. The given stuff I know is P, Q, R, S is a parallelogram. That is given. The other thing that is given is PQ is congruent to QR. Now I don't see a picture here, so I'm going to put a picture in. Get a parallelogram here. There's a parallelogram for us. And PQRS. So PQRS. And it says that PQ, the top, is congruent to QR, the right side. And it wants us to prove that this thing is a rhombus. So in order to prove that this is a rhombus, we know that the definition of rhombus says that all 4 sides must be the same. So that's what I'm going to try to do. I'm going to try to get all the sides to be the same here. So as I look at what is given, I know that I have a parallelogram, and I know that PQ and QR are the same. Well, because it's a parallelogram, I know that both pairs of opposite sides are congruent. So my line 3 is going to be based on that information. I'm going to say that PQ is congruent to SR. The top is congruent to the bottom. And also, I can say that PS, the left side, is congruent to QR, the right side. And the reason for that, and you can see that down there in the statements, that is right here, it is my first statement. That's the statement that I'm going to use in line 3. And the reason for that, as I look on the right side, is because the opposite sides of a parallelogram are congruent. So opposite sides of a parallelogram are congruent. So that tells me that PQ, all right, and now I could do either substitution or a transitive move here. If you look in line 2, it says PQ and QR are the same. So that means I'm taking line 2 and line 3. PQ is congruent to QR and PQ is congruent to SR. So that means QR must be congruent to SR. And again, PS is congruent to QR and PQ is congruent to QR. So that means PS has to be congruent to PQ. So now I have PQ congruent to QR, I have PQ congruent to SR, and I have PQ congruent to PS. So with all of those, this is the transitive for substitution property. And now if I look at lines 2, 3, and 4, since PQ is congruent to all 3 of them, you can see that QR is congruent to the other 3. You can see that SR is congruent to the other 3. And you can see that SP is congruent to the other 3. So I have all of them congruent to all 3 other sides. So this is again the transitive property. it allows me to say that all of them are congruent. And if all four sides are congruent, then it's a rhombus by the definition of rhombus. So that is the definition of rhombus. I did not want you to do the entire proof, but I just thought it might help you understand why line 3 is what it is if you were able to see that whole proof. So that's the end of page 3.